All right, so now we're going to talk about perpendicular and angle bisectors. A perpendicular bisector is the line that forms a right angle against a segment and intersects at the segment's midpoint. Okay, oftentimes, it looks like a T, an upside down T. Okay, so boom, boom, forms a right angle. And this would be the midpoint here. Well, here, let me do this in a different color. This is the midpoint, and it splits this into two congruent parts. The perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the point of the midsegment, the endpoints of the segment. So this is kind of what I was talking about the other day when I was saying we have the perpendicular bisector here. Okay, here's the endpoint, here's an endpoint, and the perpendicular bisector goes on. This point here is the same distance to this point on the left as it is to the point on the right, because the line itself bisects the segment, which means it is in the middle of that segment. So if that whole line is in the middle, then the distance from this middle point, this point on the bisector, to the point on the right is the same as the distance from the point on the bisector to the point on the left. The converse of the perpendicular bisector theorem says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So if we have a point P that is equidistant from A and B, then the line that goes through P, there's a line that goes through P that is the perpendicular bisector of that segment. In this example, it says, using the perpendicular bisector theorem, what is the length of AB? Well, the perpendicular bisector theorem says that from a point on the perpendicular bisector, so in this case, point B is equidistant, so it's the same distance from A to B. Same distance. So that means that we can set 4x equal to 6x minus 10 to figure out what x is. Mosey this guy on over the other side. And then get x by itself dividing by 2. And x is equal to 5. Okay, we know what x is equal to. Now we want to know what the length of AB is. AB is this orange line right here, which is 4x. So AB is equal to 4x, and 4x plug in 5 means that AB is equal to 20. That is one way we can use the perpendicular bisector theorem. The angle bisector theorem says that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Okay. So, again, same idea. If there's a point on this bisector, so point S is here, then the point is equidistant from the sides of that angle. So then you can draw. So then we know that this side is congruent to this side. The converse of the angle bisector theorem says that if a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. So in this picture, you see that S is here and the segments created are congruent. So we know we can draw a bisector through point S. So it says, using the angle bisector theorem, what is the length of RM? Okay, we want to know what RM is equal to. Well, we know that NR bisects angle LNQ, which means that RP is equal to MP. Oop, I covered some of the problem. Is equal to, RP is equal to MR. So we can set them equal to each other. 7x is equal to 2x plus 25. Get x on one side. And then isolate it. We know what x is equal to. We want to know what Rm is equal to. Rm is equal to 7x, 7, plug in x, 7 times 5 is 35. Excuse me, sorry. So Rm is equal to 35.